Dear students, in the previous class we have discussed AR1 process and its properties. Now we consider AR2 written as yt is equal to delta plus phi1 yt minus 1 plus phi2 yt minus 2 plus epsilon AR2 process. And assuming that the condition for stationarity is satisfied, that is phi1 plus phi2 less than 1, mean of the series is expected yt is equal to delta by 1 minus phi1 minus phi2. Expected yt 1 minus phi delta by 1 minus phi1 minus phi2, and the condition for stationarity phi1 plus phi2 less than 1. That is the necessary condition for stationarity. Now we let delta equal to 0. That is, we rescale the process as a zero mean process, so that gamma 0 is equal to expected yt square. Expected yt square. That is, expected value of phi1 yt minus 1 plus phi2 yt minus 2 plus epsilon t into phi1 yt minus 1 plus phi2 yt minus 2 plus epsilon t is equal to expected value of it is more convenient to write it in a different format. Expected value of yt phi1 yt minus 1 plus phi2 yt minus 2 plus epsilon t. 1 yt is substituted. Delta is equal to 0. Is equal to expected value of phi1 yt minus 1 plus phi2 yt minus 2 plus yt epsilon t. And if you take the expectations inside, you will get gamma 0 as equal to phi1 expected yt minus 1 is gamma 1 plus phi2 gamma 2 plus this expectation of yt epsilon t. Yt epsilon t is, if you write a yt as phi1 yt minus 1 plus phi2 yt minus 2 plus epsilon t into epsilon t, and if you take expectations epsilon t yt minus 1 0 yt, but there is expected value of epsilon t square, that is sigma square epsilon. So what is gamma 0? Phi1 gamma 1 plus phi2 gamma 2 plus sigma square epsilon. Now let us see what is gamma 1. Gamma 1 is equal to expected value of yt minus 1. So yt minus 1 into phi1 yt minus 1 plus phi2 yt minus 2 plus epsilon t. Expected value of yt minus 1. And this is equal to phi1 then yt minus 1 square expectation gamma 0. Then yt minus 1, phi 1, yt minus 1. So phi 1, yt minus 1, yt minus 2, gamma 1. Yt minus 1, epsilon t 0. So what is gamma 1? Phi 1 gamma 0 plus phi 1 gamma 1. Then gamma 2 is equal to expected value of y t minus 2 into phi 1 y t minus 1 plus phi 2 y t minus 2 plus epsilon t is equal to, as you can see, it is equal to phi 1 gamma 1 plus phi 2 gamma 0, that is gamma 2. And in general, for k greater than 2, what is gamma k? Expected value of y t minus k, phi 1 y t minus 1 plus phi 2 y t minus 2 plus epsilon t is equal to phi 1. So gamma k is equal to phi 1 gamma k minus 1 plus phi 2 gamma k minus 2. For k greater than 2, gamma k is equal to phi 1 gamma k minus 1 plus phi 2 gamma k minus 2. So let me write these results alone. Gamma 0 is equal to phi 1 gamma 1 plus phi 1 gamma 2 plus sigma square epsilon. Gamma 1 is equal to phi 1 gamma 0 plus phi 1 gamma 1. Gamma 2 is equal to phi 1 gamma 0 plus, gamma 1 plus phi 1 gamma 0, and generalizing it, then gamma 3 is equal to phi 1 gamma 2 plus phi 1 gamma 1, and gamma k is equal to phi 1 gamma k minus 1 plus phi 1, these are all phi 2, not phi 1. Phi 1 gamma 0, variance is phi 2 gamma 2, phi 2 gamma 1, phi 2 gamma 0, phi 2 gamma k minus 2. These are the values for k greater than 2. This is the mean, variance, covariances. Now, by substituting, it involves a lot of procedures, so I simply skip these steps. We can write gamma 0, the variance as equal to, that is by substituting from gamma 1, gamma 2, etc. We can write gamma 0 as equal to 1 minus phi 2 into sigma square epsilon by 1 plus phi 2 into 1 minus phi 1 minus phi 2 into 1 plus phi 1 minus phi 2. That is the variance of the process. To derive this, you have to make a lot of substitutions. If you want to practice, you can do it. Then this mean condition for constancy of mean is phi 1 plus phi 2 less than 1. Condition for constancy of variance is phi 2 plus phi 1 less than 1, phi 2 minus phi 1 less than 1, absolute value of phi 2 less than 1. These are the stationarity conditions for a AR2 process. Stationarity conditions for. Otherwise, if these conditions are not satisfied, you can substitute these values in the variance formula. Variance become infinite. So for the AR1 model, the only stationarity condition is absolute value of phi 1 is less than 1. For AR2, stationarity conditions are 3. Or stated differently, all the roots lie outside the unit circle. Both are same. Now we derive the autocorrelation functions, ACF. To derive this, consider gamma 1 and also gamma 2. Now, this gamma 1 by gamma 0 is equal to phi 1 plus phi 2. Gamma 1 by gamma 0 is 1. And so gamma 1 by, that is rho 1 is equal to gamma 1 by gamma 0, and rho 2 is equal to gamma 2 by gamma 0 is equal to phi 1 rho 1 gamma 1 by gamma 0 plus phi 2 gamma 0 by gamma 0. Now, these equations are known as the Yule-Walker equations. Yule-Walker equations for AR2 process. Yule-Walker equations for AR2 process. Rho 1 is gamma 1 by gamma 0. Rho 2 is gamma 2 by gamma 0, obtained by dividing both with gamma 0. And variance is given by this. Substituting the values for gamma 1 and gamma 2 in this equation and solving. Now, solving these together, first rho 1 is equal to phi 1 by 1 minus phi 2, and rho 2 is equal to phi 1 square by 1 minus phi 1 plus phi 2. So rho 1 is equal to phi 1 by 1 minus phi 2. Rho 2 is the value of phi 1 is substituted, phi 1 into phi 1, phi 1 square by 1 minus phi 1 plus phi 2. Now, then the ACF for k greater than 2. ACF for k greater than 2. This is for 1 and 2. Rho 1, rho 2 can be calculated as rho k is equal to phi 1 rho k minus 1 plus phi 2 rho k minus 2. Because gamma k by gamma 0, phi 1 rho k minus 1 by gamma 0, rho k minus 1, then rho k minus 2. And as you know, this is rho 1 and this is rho 2. So what is rho 3? Rho 3 is equal to phi 1 gamma 2 by gamma 0 rho 2 plus phi 2 rho 1. Since rho 1 and rho 2 are given by the Yule-Walker equations, rho 3 can be calculated. When rho 3 is calculated, then rho 4 can be calculated. In that way, we can calculate up to rho k. This is the ACF, autocorrelation function. And when we plot this autocorrelation function against k, you will get the correlogram. You will get the correlogram like this. 0, 0.5, 0.5, and the process is something like this. So like this. And this process is written for the process yt is equal to 2 plus 0.9 yt minus 1 plus, minus 0.7 yt minus 2 plus epsilon t, the graph. And this graph is sinusoidal function. So, for an AR2 process, the autocorrelation function may be geometrically damped, oscillating, or sinusoidal. All these patterns are possible. Geometrically damped, oscillating, sinusoidal. All these patterns are possible for an AR2 process. So, for an AR1 process, only geometric decay. But when you go beyond when you go beyond AR1, for AR2 process, many patterns are possible. If this is the mechanism generating, it is sinusoidal. Other patterns are oscillating, geometrically damped, etc. And we will generalize this later for an ART process and for an MAQ process after considering this. So we will not follow AR3, 4, etc. And our generalization is for AR2 and above. The pattern of autocorrelation function may be sinusoidal. Sinusoidal means the pattern is something like this. Then oscillating pattern, again oscillating, or geometrically damped. All these patterns are possible for AR2 and above. So we have discussed MA process and AR process, and in the next we will consider the combination of AR and MA, namely ARIMA process, and we will derive its mean, variance, covariances, autocorrelations, etc.